This is a continuation of the tangent line and normal line PowerPoint, and I'm Ms. Scheltz. So we had the graph and the idea, but so let's actually write the equation of the tangent line at 0, and then we'll use that line to approximate it at 0.12. So the tangent line, y minus equals m times x minus, x1 is 0. We could also just put nothing, clearly. And then to find the y1, you substitute in here. So if you substitute in 0, you get y equals the square root of 4 plus 0, sine 0 is 0. The square root of 4 is 2, so my y2 is 2. Now to find my slope is the same as the derivative. So I'm going to need to take the derivative of this function. All right? It's calculus, derivatives have to come in separate, right? So I'm going to rewrite it first. So let's do this. Rewrite. Okay, rewrite it as y equals 4 plus sine of x to the half. Take a second, pause the video, find the derivative of that. All right, here it is. 4 plus sine of x to the negative 1 half times cosine of x. Let's do the chain rule because the derivative of sine is cosine. All right, now I'm going to rewrite that again. So rewrite, differentiate, and now simplify. Those are our 3 major steps that we do. So y prime, I'm going to play the numerator and denominator game. So 1's in the numerator, I'm not going to write anything. 2's in the denominator, 2. This guy, is this term in the numerator or denominator? Negative exponent, denominator. 1/2 means it's a square root. Okay. Cosine is just in the numerator. So that's in the numerator. So to find what this slope is, I'm going to substitute in, what do I do? I substitute in 0 here. All right, so I'm going to replace these with, I'm running out of room. Find it over here. I'm going to find f prime of 0 equals cosine of 0 over 2 times the square root of 4 plus sine of 0. Cosine of 0 is 1. 2 times the square root of 4, we know sine of 0 is 0, so the square root of 4 plus 0 is the square root of 4, which is 1 over 2 times 2, which is a fourth. So that's my m. Alrighty, now, I'm still not done the problem. This is quite a long problem. But now I need to use the tangent line to approximate the value at 0.12. So now is when I use my 0.12 and plug it in. So I wrote the tangent line at 0, and now I'm using the tangent line to approximate the y value at 0.12. Y minus 2 equals 1/4. X is 0.12 minus 0. A fourth of 0.12 is 0.03. Don't accidentally say it's 0.3. Oops. Had 3 on the mind. Plus 2 to both sides is 2.03, which is B. All right. Oh, I need to plug this in here. Okay. Now this one. Let's see. This is saying, what's the equation? I'm going to have you do this completely on your own. An equation of the line normal. It's luckily that you underlined the word normal. Normal to the graph of y equals that cubic function at the point where x equals 1. So the only way that this is similar to the last one in that you will need, we'll just like start it all together. You have y minus y1 equals m times x minus x1. So you know your x1 right off the bat. You don't know your y1, but you can find it. So think about what you used to find the y1. And then you don't know your m, but you can find it. Okay? And then make sure you do the normal. All right? And then you're going to have to put it in standard form to see which maxes. And just be really careful with putting it in standard form so you don't make a little mistake. And so, yeah, it's going to stop the video and ask you to select an answer, and then I'll go through it with you. And we're back. We're back. All right, so I found the derivative first, so I'm looking for my m first. So that's my derivative. I'm substituting in 1, so I get 4 as my derivative. I don't use the derivative, I use the perpendicular slope of the derivative, so the normal slope is -1/4. And then I found this y, I didn't show how I found this y value. So to find the y value, I substitute my 1 into the original. So if you substitute 1 into the original, 1 plus 3 plus 7 minus 1 is 6. Okay. Now when we do that out, I don't distribute first, okay? This is a good trick. I want to get rid of my fraction as soon as possible. So I'm going to multiply everything by 4. So 4y plus 24. And when you multiply this whole term by 4, it just makes the -1/4 become a negative. Oh, and then I distribute it all at once. So the step you're not seeing here is -1 times x plus 1. So when you multiply everything by 4, makes that, and then I distributed the -1. Pause. And then I simplify it, and I'm trying to get it to its standard form, and it was e. All right, it was e. All right, let's move along. Let's do number 5. You're also going to do this one on your own. I'll talk through it a little bit. An equation of the line tangent to the graph of this quotient, quotient at the point 1,5. This is nice. It gives you the y value. It's also asking for it in standard form. And this is just a tangent line, not a normal line. So go ahead and do that. Remember, with the quotient, you're going to have to use the quotient rule to find the derivative, right? So remember, you have two options. You can do the whole quotient rule and plug in at the very end and embrace variables. I think it's a bad idea. Or you can plug in when it's in the low-d-low, high-d-high form. I think that is quicker and leaves less room for mistakes. But anyway, do that out and then we'll come back. Alrighty, and we're back. This is my quotient. You substitute in basically my low is 2, my d high is 1, my high is 3, my d high is 5 over 1 squared. So I get -13. When I write that out, this is my slope-intercept form. So no fractions, so I don't have to do that like the last problem. Distribute out, and I add the 5 to both sides, which yields, and then I put the x over there, which is b. Okay. Next one, an equation of the line tangent to the graph of y equals cosine of 2x at pi over 4. So this is another one. It gives you the x value, but it does not give you the y value, and it doesn't give you the slope. So again, when you have y minus y1 equals m times x minus x1, I'm just going to go straight up and put it in there. Boom. It doesn't give me my y1, however, but you know how to find it, right? It doesn't give you my m, but you know how to find that. Be careful taking the derivative of this, just be careful. You have to use one of our rules. So we'll let you go too, and then we'll join back. And we're back. All right, so I'm finding the derivative. This is the derivative. The derivative of cosine is negative sine of 2x. And then you multiply by 2. So some of you might have written negative sine of 2x times by 2 using the chain rule, but the 2 goes out front. What's the answer going to be? The answer is going to be e, by the way. All right, so I'm simplifying. That's 90 degrees, sine of 90. I don't use my unit circle. I personally use the graph. So is 1. So it's just -2. Cosine, to find my y value, I plug into the original. So the original y value is 0. So this down here, y minus 0 is just that. And it's this answer, which is E. Alrighty, this line normal to the curve of this one at the point 0,4 has a slope of this. So you're just finding the slope. Let's move around. Come on, guys, come on. So you're finding the slope. Okay. So I'm going to pause the video, read it carefully, take the derivative carefully. All right, you're going to have to rewrite. Rewrite, differentiate, simplify. Do that whole thing. Rewrite, differentiate, simplify. Do that. Take your time and go ahead and do it. We'll join back. All right, and we're back. All right, so I rewrote it as 1/2. The derivative is 1/2, 16 minus x to the negative 1/2 times -1. It's the derivative inside. You got that? You know, a little pat on the back is good. Rewrite that first. Before substituting in, that's the rewritten form. I'm going to substitute in 0. You get -1/8. That is the slope, that is the derivative. That is not the normal slope, okay? That is not the normal slope. So in terms of annotating, if you didn't annotate this, good idea to annotate. So the normal slope would be 8a. All right. Now we got the next, ABQ 9. We are going to do this, are we going to do this together? Let's see here. This is not, I think we already did this one. Yeah, go ahead and do this one on your own. Go ahead and do this one on your own, and we'll join back in. And we're back. All right, so this is the derivative, 1 minus sine x. When you substitute in 0, you get 1. So this is the equation, which is b. All right, now, oh my god, so many things. Find the equation of the line normal to the curve of this. So this can be done, of course, with implicitly defined functions. This can be done with implicitly defined functions. So when you do this out, I'm just going to go through this together, and the next one you're going to do on your own. So when you do this, you're subtracting, and you're subtracting a product, so just be careful to use brackets or parentheses. The derivative of 7 is 0, so make sure you're setting it equal to 0, okay? You might have written it like this also, and just had the u be negative x. Here I had the u be positive x, and then I subtracted it. So here I did like, whatever. So you might have had either this or that, both of those are fine. And I substitute in right away. Remember, we learned from the do now, you know that long do now we did on today, it was Monday. To substitute in right away. So I substituted in right away, I'm simplifying, dy dx was -4/5. So the normal line would be that. All right? So this can be done with implicitly defined functions too. Alrighty, let's do APQ 9 mostly on your own. All right, so you're going to do the solo. This is the last one. You've almost made it. The slope of the line tangent to this curve at this value, okay, is this. Now, before you go and take the derivative, before I leave you go, this derivative you should be good with. This derivative is a little bit tricky. You're going to do 3, inside stays the same, squared, times the derivative of the inside. Now the derivative of the inside, you're going to have to use the product rule. We know that the product rule is going to end up having 2 terms, a thing plus a thing, term plus a term. So when you multiply by the derivative of the inside, when you do like your times g prime, you're going to have to use brackets or parentheses. Make sure to do that. And then as soon as you can, practice substituting in. You just need the slope of the line at a point. So as soon as you take the derivative, I would substitute in right there. Okay? So I'll leave you go. All right, well, let's do it. And we're back. Okay, so the answer is D. So if you got that, you can probably shut off the video. Good job. So this is the first derivative. Notice my use of the brackets here for multiplying by a sum. Now I substituted in right here. Wow, it's so long. It's a -1, 3 times 2 times 2 times -1 plus 1. 3 times -1, in parentheses 2 times -1 plus 1 squared. All right, it ends up being -2 dy dx plus 6 dy dx plus a -3 equals 0. So that's 4 dy dx equals 3, dy dx equals 3/4. All right, and that's it. Thanks for hanging out with me this whole time and learning about tangent and normal.